So my name's Earl Ruby, and I'm a principal software engineer here at Apcera. I work mostly on storage problems, solving storage problems here, and I've been here almost 3 months now. If you don't know about Apcera, we've been around a couple of years. This time last year, there were about 15 people working at Apcera. Now there's about 100. And we build an application platform that is an entire, it helps people deploy containers, build applications, into do dev, test, production, scale applications up, but do so in a policy-driven, secure, thoughtful manner. So, excuse me. As I said, I work at Apcera. Last year I got to speak at Recon. They asked me for a picture for their speakers gallery, and I sent them that. So when they had the big rogues gallery of all the speakers there were lots of people in suits and ties, and very professionally done, and then there was me. People showed up at my talk, I'll tell you that. So storage, and today storage covers a lot of ground, and so I'm going to try to keep this to about 20 minutes and narrow it down. So I'm going to talk about file system storage specifically and as it relates to policy. We're going to have a Q&A session afterwards, and there's some, Peter Buckingham over here is also going to be helping with the Q&A, as well as Gao. And so we'll be taking more questions from the audience. But if you want to interrupt me and ask questions, that's fine too. I'm happy to answer questions as we go along. So to focus this talk, I wanted to talk about what problem we're trying to solve. And we solve a lot of problems at Apcera. Like I said, we build application platforms that allow you to do dev and test and QA and production all in the same environment, in the same cloud infrastructure. We allow people to be cloud agnostic, so they can move things from their local on-prem cloud to Google Cloud to AWS, wherever they want. Combinations of all of the above at the same time also works. We try to make applications that we try to make it so that you can easily build applications that scale. We do that by focusing on microservices and making it so that each part of your application can scale up independently of the others. And those are all very interesting. But one of the big problems we actually try to solve is we want to reduce the development time, the time that developers spend developing applications. Because with a large group, if you're in a big corporate environment, an enterprise environment, and you've got a couple hundred or a couple thousand engineers working and developing software, big corporations tend to silo some of that stuff apart. So you're a developer, you want a database. You have to go to the database guy to provision that. You want network access. You have to go to the network guys to get the routing set up. You want some storage, some file system storage. You have to go to the guy that administers the SAN to get your storage set up. And that takes time, and it slows down development cycles, and it adds bureaucracy to the system. And to bring up, and there's good reasons for that, because you said earlier, tightly coupled. You want to decouple storage from the development process. And right now it is tightly coupled, and that's one of the reasons why there is a bit of bureaucracy in larger enterprises, is because if you just let a developer do anything they wanted with the storage, they might break it. Or if you let them put anything they wanted on the database, they might not have the right index there or build something incorrectly and bring the whole database system down. So you want to be able to, you have people that are administering the big databases, the big SANs, the big file servers. You want them to be able to allocate resources to the developers so that they can build their applications, but without compromising the system security or the stability as you're doing so. So that's the problem we're really trying to solve. And I'm going to bring up a couple of examples, a couple of use cases, and talk about each one of those and the problems associated with them. So 3 simple use cases: temporary file system, single job. And you can think of a single job as a single container. Persistent file system to a single job, so it stays around. Persistent file system shared with multiple jobs. So 3 very different use cases, all file system oriented, all with containers. You want to be able to do these in any cloud, anywhere, so we can't use features that are specific to one cloud and not another. So in the temporary file system single job, It's not that interesting of an application, but job starts, let's get it to the file system. And then there's the question, how much data does that file system get to use? Job writes to the file system, what kind of performance is it going to get? You've got a lot of containers on the same box. You brought up earlier, you can start having contention for resources. If the data is stored locally on the same host where the job is running, which current Docker implementations tend to do, that limits your total available volume size because you're limited by the space on the local host. You also have a single point of failure in that case. The job ends and the data goes away, hence the name temporary. And right now, Linux containers handle this pretty well today, so this works. But there are some trade-offs and some drawbacks and some things that can cause you problems. Persistent file system, single job gets a little more interesting. Job starts, has one file system. Job writes data to the file system. Still, you got the question about performance, how much performance you're going to get. You migrate that to a new host. The data should move with it, but how quickly? So is the job going to be down for a while the data catches up? Do you move the job and then the data? So do you try to do it sort of synchronously? These are all questions. Job restarts, the data persists. How durable is it going to be? Do you want it to be on RAID? Do you want a 3-copy system? When the job ends and the data goes away, you got to have someone to tell the difference between a restart and end. When the job the job died, and you want to restart it at some point, but there's a difference between restarting it where, okay, I want that to come back with the same data versus ending, and I don't care about the data anymore. I'm never going to see that job again. I don't care about it. Delete the data. So you've got to track these things. There is the persistent file system. Now this is more interesting. Persistent file system shared multiple jobs. So now you got a whole bunch of jobs, a bunch of containers. They're all accessing the same bit of file system. They're all accessing the same data. Now this gets it really can get tricky because the first job starts, gets the file system. Once again, you've got the data quota. You've got more jobs start. They can access the same file system, but how many jobs can actually do that at the same time? How long before you start grinding that system to a halt? Jobs write data to the file system. How many jobs at the same time? Are they writing to the same file? Are they writing to the same directory? You're going to have locking problems. You're going to have contention problems.
Where's this file system running?
Good question. What kind of a file system are you running? Where is it running? Is it on the same? There are multiple. You've said yourself when you go out to a company, they've got different things that they're using, different kinds of file systems. They've got old legacy SANs out there. They might have some Fusion IO really fast drives. They might have some spinning disks a little slower. What is it running on?
So just to be clear in terms, since job is container, so is this an example of a pod where they got to run on the same machine, or are you doing something more abstract where there are multiple jobs on multiple boxes?
So a distributed file system versus a single local file system.
Yeah, I'm trying to ask you. I'm asking what you're saying though.
Actually, I interpret this as a job, which is a container, getting its data, for example, from an NFS server.
Yeah, that's one way of doing it. When we talk about, we use a little bit of different nomenclature here. It took me a while, the first week I was here, to get used to it. And I finally, somebody pointed me to the jargon file, which was like the internal Apcera jargon file, which doesn't necessarily translate to the real world. But we have jobs, which you can think of as, it could be something like a bash. It's more or less a Linux container doing a specific microservice. We have what's called a capsule, which is a container, which is basically a minute little operating system you can log into. And we have applications, which are, it could be something like just like a bash script that's bound to a process that's running inside this namespace, inside of its own namespace. But in the case of this application, we're talking about a job that is attached to file storage somewhere. And it could be NFS, it could be local disk, it could be iSCSI, could be a number of different ways of doing it. So, but the question is, if you've got some infrastructure you're running on, you've got some stuff on-prem, you're testing it there, maybe you're moving it off to Amazon eventually, how do you know it's going to scale? How do you know it's going to work? How do you know how many jobs you can run with it? These are all interesting. And when you get to the will it scale question, that gets to even more interesting questions, because then you have to define what you mean by scale. Because some people, when they say scale, they're talking about large amounts of volume. They're talking about petabytes or exabytes of data. Some people are talking about the number of simultaneous read, write, and update operations that you can do on your data at the same time. Sometimes it's the number of simultaneous connections to your data source. Sometimes it's the total IOPS, or gigabits per second, that you can do to that file system. And then we get to the noisy neighbor problem that you also brought up earlier, where you've got one container on your host and it's hogging up all the resources and starving all of your other containers for resources. Some people scale means the CAP theorem: consistency, availability, partition tolerance. Other people would just want predictable performance as everything increases. They don't really care. Well, they care a little bit about what performance is, but they want to make sure that that performance stays predictable as their scale increases. And the real answer is it depends on your application. Your application, depending on what the application wants to do, different things here are important to it. Some applications are very happy with just a tiny amount of data, but they want a lot of different jobs to be able to read that data at the same time. Other applications want to write to that data occasionally and have all the jobs get updated. So it really, so when you're talking about scale and you're talking about storage, a lot comes back to what does your application need? And there are different kinds of storage out there that have different characteristics, and they vary in cost by quite a bit. So when you get back to so some of the trade-offs here, you've got NFS, all the traffic's across your network, so you've got network contention. It tends to degrade if many jobs are writing to the same file directory because it has locking issues. If you've got a local SSD, that's great. It's fast, but your total space is limited to the size of the disk, and it's a single point of failure. HDFS, popular with Hadoop, but it's optimized for large files and sequential reads. You don't want to be using that for doing in-place updates because it can't. EBS works only on Amazon, and it can get expensive if you want lots and lots of IOPS. Glacier, it's cheap to store, it's slow and expensive to read. Optimized for large files. You write once, you read rarely. And then your legacy SAN example, where you go into some place and they've got a SAN on site. It's fast, it works for the on-prem cloud. It's not going to work in AWS because it's on-prem, and it's expensive if you need to maintain or extend it. The older they get, the more expensive they are to run. So what we talk about with this is policy. So if you use policy for provisioning and security and performance and business logic, then instead of trying to redesign the wheel and trying to get the developers to figure out this is how we need to architect it, the developers just have to say, hey, this is what I need for my application. For my application to work, I need these types of things. Now let the platform go out and figure out how to deliver that to me based on what's available on that platform. So when we talk about policy, we talk about things like disk quotas, max capacity. We talk about, do you need geo-replication for high availability failover from one geographic location to another? Do you need data durability? So do you care if you lose this little bit of data that this particular container is talking to, or does it need to be durability with 3 copies distributed on a distributed file system where if anything fails, it just keeps on running? What kind of performance do you need during recovery from a hardware failure? So if you've got a 3-copy system and you lose one of your servers, and then you put a new server in place, that new server has to be populated. There's a performance penalty while it's recovering. These are the things you can address with policy. Do you need thick provisioning? Or will thin provisioning, is that okay for your application? You can set policy for these things. Performance policy. Once again, you can set min and max IOPS and talk about what kind of performance you need for your application to work. How much bandwidth is it going to need? If it's going across the network, is there a minimum of bandwidth you always want to reserve for it so that nobody else takes that bandwidth? Is there a maximum amount you want before you shut it down and you say no more? Is there a latency requirement? You have to be able to get your data within a certain amount of time? Is there a maximum number of concurrent access? And when I say max, it's not do you want to limit it. It's more like what do you expect it to get to, in terms of provisioning. And I encourage people not to define that this needs to run on an SSD or this needs to run on a hard drive or this needs to run on a SAN. Just define the performance you require. Let the platform figure it out because. As Elizabeth pointed out earlier, Intel's coming out with new technology. There's new stuff coming out all the time, and the performance characteristics of your storage will change. I was talking to a guy at a vendor who shall remain nameless, and they were deploying petabytes of storage, object storage, And he was telling me that when they would first deploy a cabinet of a rack of their equipment with 6 servers in it, their customers typically would populate one of those servers with a lot of SSDs, and that would be their top tier storage really fast, and the rest would be hard drives. But then over time, as they added more and more servers with hard drives, the hard drive storage actually got faster than the SSDs because they kept adding them. They never added any more SSDs, and so their tier 2 actually became faster, even though it was on spinning disks, so it was distributed across more disks. So I encourage people, do not think of SSDs as necessarily faster than hard drives. It really depends on what your infrastructure looks like. And then we have data handling policy. Do you need deduplication of this data? Do you need compression? Do you want at-rest encryption? And everybody wants at-rest encryption. Do you want pointed? And the only reason we even make it an option, we're going to default it to yes, by the way, but the only reason we even put it in as an option is that if you are attaching to some sorts of storage platforms, they're not going to support that. Do you, so if you have in your policy that you have to have it, then you can't use those types of storage. If you say, I don't care, you can use what's available. Do you need point-in-time recovery, snapshotting, cloning? Do you need a schedule of point-in-time recovery? So do you want regular backups scheduled of your data so that you can recover to those point of times from a full backup? These are all policy questions. Then there's business policy that gets into I know that I'm using Glacier for this and I'm using EBS for this other thing, and they have a cost per gigabyte per month. And so you could assign those. You could actually have a policy around price. I have this service I'm going to provide. I'm making no money for it. I want it on the cheapest storage I possibly can because it's just a giveaway, a throwaway. There's a location policy. Some people are very concerned about jurisdictional matters. So they want to make sure that their data stays inside their country. So you could, or within a group of countries, or within a certain locality. So you could actually set up, tag your host with the location, tag your storage, this abstract storage job with the location, and it will only be located on servers within those countries. And then there's also retention is another business policy. How long do you want to keep this data for? Some data you want to keep forever. Some data you want to delete it when the user says delete it. And some you want to keep it for a certain period of time, after which you don't want to keep it around. And this is a big issue with compliance. Because it's common, big companies, it's common for one company to sue another company and just try to swamp them with legal bills in the discovery process. They'll say, oh, we need you to search all your emails going back forever and ever and give us all your data. And if you say, well, we have this policy in place and we delete all of our emails after a year, guess what? You only have, as long as the policy's there, that's a legal reason to only have to give them a year's worth of email. And that's important for some big companies. So, what this all gets down to is that with these policies wrapped around, we still have to play nice with others because we want to be able to connect to other vendor storage solutions. We want to be able to determine what policies those solutions support. We have to apply policies that are supported by those solutions. And then we react gracefully when policies are not supported. And that means the software, not me personally, but I can rant and rave, but the software should react gracefully and it should self-heal if the policy is not supported. And I'll give you an example. So if you did deploy, let's say you did deploy something and you had a policy that says I must have at-rest disk encryption, and you had a bunch of other policies that dictated other things, and it turned out that the only storage that you even had on your system that could meet all your other policies did not support the encryption, the software should come back and say, hey, you know what? I can do what you want except for this one thing. If you say no on this, then I can go ahead and implement this job and roll it out. Do you want to do that? And you say, okay, I'll change that policy, and then it rolls out the job. So that's the example of self-healing, going back to the user and asking them. And right now, you mentioned earlier NFS, and for Apcera jobs, we currently supply NFS volumes. We do persistent storage to Docker containers. These are things that we're rolling out today with our product. We're actively engaged with other players, Cluster HQ, Flocker, ObjectiveFS, and Converge.io, among others. Apcera is part of the Open Container Initiative. And right now we have quotas and access permissions are supported by policy today. And the rest of it, okay, I'm sorry, here's some policy examples. I'll show you some of these. Here's one. This is an actual policy from our documentation. limits package size, RAM, disk, network resources for a user, for SAMs, sandbox namespace. Without such a policy, SAM would have an unrestricted use of resources, and you can see there's like total disk, total network, total memory in there.
The problems that you listed before,
Mm-hmm.
for example, same data being accessible across clouds,
Mm-hmm.
is that something that?
That is in progress. So a lot of that's in progress. Like I said, right now we've got, right now what we're delivering is NFS volumes on Apcera jobs, persistent storage of Docker containers, and these other things. We are working. The other things are things we are working towards. So as you said, you're trying to ship your product out, and you've got you're thinking big and thinking of what you're going to do. These are the directions we're going, and what we're implementing to make that happen, or the direction we're heading to make that happen. Changes can happen along the way. We may add stuff, take stuff out, rename stuff.
How do you plan to deal with that? Is there a, I mean, just like, okay, maybe offline time. Maybe
I could tell you, but you'll have to work here.
So let me ask a non-NDA question. Have you guys looked at things like Gluster or SelfHealing or any of the other policies in those areas?
Yes. And we do support, and it gets a little tricky here because there's things we connect to. So like you go out and set up a MongoDB server, and you want to use that as a source, we can do policy-driven connections to that and carve out. I don't want to get too deep into our architecture, but you can provide a portion of a service to a container in a very sandbox fashion, so that container has access. So, as a for instance, let's say you've got a MongoDB server out there, you can connect to it and provide a separate database to a group of containers. And you can do that in a programmatic fashion that is completely secure and sandboxed from every other user on that Mongo database. You can also do something like a singleton instance implementation where you just spin up a Mongo within our cluster inside a container, inside another container, and bind that to one of your containers. So there's a couple different ways you can do that, and once again, it kind of depends on what your application needs to do. And yes, we've looked at a lot of different storage solutions, and once again, some of them are better at certain. Part of the reason was when I was hired here, they told me, you need to solve the storage problem. I said, well, that's a really hard problem, and I don't think there's going to be one right answer. I think you're going to find that depending on your application, there's a different answers which are different, right, for different applications. And one of the reasons I wanted to work here was that Apcera was very focused on policy, and I knew that I really thought that was the right answer. That if you can tell, you can say, hey, I've got like S3FS. I've got this S3FS storage out there, which is great for storing large files once, write once, read rarely, and it works really well for that. But if you say, I have a policy that I've got this kind of storage available for these types of applications, then your developers don't have to worry about did they architect the storage correctly. They just have to say, this is what I need, and the system gives them that.
Did you look at all about classifying policies as mandatory versus really, really desired?
Yeah, we have the concept of a hard requirement versus a soft requirement. Hard requirement, you have.
Because usually a hard requirement for most people is.
Well, for us, a hard requirement means if you can't meet this requirement, you can't run the job. You can't start it. A soft requirement is, we would prefer if you met this as best you can, but if you can't, run the job anyways.
So the other thing, and maybe you just have to draw the line somewhere, is when I'm using cloud storage, sometimes it's often remote, and there's a fee that is not capacity-based, it's transfer-based, transmission-based. Mm-hmm. Network transfer fees are the things that aren't, and the race to zero.
Okay.
I haven't seen anybody talking about that in OCI, in the Open Container Initiative, that there's actually a cost to having storage be remote.
Yeah, there are fixed costs. There are costs that are not.
The network transaction fees are actually higher than the fixed costs.
And there are network.
I think that's outside of the scope of OCI, personally speaking.
I've seen it be outside there, but if you go back and put your application hat on again, it's not outside the scope of the cost of an app.
I got it, but what we're trying to do at OCI right now is really trying to define honestly, what the format needs to be of a container, and it's just,
It's sort of orthogonal.
It really,
Yeah. It's a little orthogonal
to this, but I mean, I could see somebody else coming out and running with this and coming up with open policy initiative or something like that, where they have a policy engine that's open.
So, but if I were to translate this question, would your policy take into account the costs associated with network transfers?
The answer is the cost is a roadmap thing, so it's not actually doing that now. So
That's even better than because, I mean, if you're going to have cost in it all, you should at least count the cost of the most expensive thing.
Yeah, no, the cost for the cost of things I'm considering are monthly fees, fixed costs, and transfer costs. Yeah. And when we look, what we do is, I mean, I look at something like Amazon, and they have costing like just like that, especially for something like Glacier. So you want to make sure you can model that correctly. Policy example 2. So there's another one. This one limits the amount of resources individual job instances can consume. I've got disk on there, network again, memory, CPU. Here's another policy block. This is total amount of resources all jobs may consume. And another one, maximum instances in the prod namespace can consume, maximum memory interspace each job may consume. And when will we get there? This is one of my favorite quotes. Where are we going? Planet 10. When will we get there? Real soon. I don't know if anyone's a Buckaroo Banzai fan, but real old movie. But we are working to get there rapidly. We are hiring, so if this tickles anyone's interest and they say, this is something I want to work on, talk to me afterwards. And thanks for listening. That's it.